Hello everyone, my name is Protesilaos, also known as Prot. A few days ago, I announced that I am learning the Clojure programming language. I am learning this language in an effort to acquire new skills that will help me in my search for a job. Hopefully, those skills will improve my chances at the labor market. So what I want to do in this video is provide you with an overview of Clojure and the Clojure setup in Emacs. So I want to talk to you about the two packages we need to start developing Clojure with Emacs. And then I want to show you a little bit what Clojure is, how it looks like, and what is the kind of workflow we have when writing in this programming language with the help of Emacs. The two packages we need are clojure-mode, which is a major mode that reads the relevant Clojure files. It provides syntax highlighting, indentation, that sort of thing. And then we have CIDER, which is the interactive development environment for Clojure, which is what also gives us the REPL and all the other goodies, but we will see these in practice. What I have here in front of me is just an empty directory with a single file. The file has no contents, it's an empty file. And what I want to do here is to start demonstrating clojure-mode, CIDER, and Clojure, the language, within Emacs. When you are in a Clojure file, the first thing you want to do is to bring up the REPL, so to enable the evaluation of your code in an interactive fashion. And doing this is how you develop code with Clojure. It is a very pleasant way of writing code and seeing the results on demand. The way you do this is with the key binding Control-C, Meta-J. This runs the command, as you can see in my mode line, CIDER jack in CLJ. And this will bring up the REPL. Normally, when you are in a real project, you have your dependencies declared, you have your namespaces. So when you run the REPL for the first time, it will fetch all those dependencies. It will set everything up for you to start developing that project. However, here I have an empty directory, a file with no contents. So CIDER is asking me whether I am sure that I want to bring up a REPL for something that does not have a project associated with it. And this is the prompt at the bottom of the page. So I will just say yes. It is now running the server. It takes a second. So here we are. I have my REPL over here. Let's just dismiss the other window for now. REPL is an acronym that stands for Read, Evaluate, Print, and Loop, which is a fancy way of saying that you type in some code, you hit the return key, it prints the value of the code that you wrote, and then it puts you back in the prompt so that you can continue more of the same. Okay. When you are in the REPL, in here the CIDER REPL, you can start evaluating actual code. So for example, I want to define a variable. I will call it hello. And I want to give it a string value, which is hello world, like this. And if I hit the return key now, it defines the hello symbol. And if I now type hello and hit the return key, it gives me the value of that symbol. So I have bound the string hello world to the symbol hello. This is great. So I can continue using the REPL to define all my code and then to get the results I want. However, this is not very efficient in my opinion. It is better to use the full power of CIDER to actually evaluate code in its context. And this means to evaluate it within its own files. So within the closure mode files. So I am now switching to the file that is associated with this REPL. It is empty, but let's start defining some symbols over here and see how it goes. So I will define a variable again, define hello, and I am calling it hello again. Hello once more is the value associated with this. So I have written my code, and now I want to evaluate. I could copy this into the REPL and then hit the return key, and that would get the job done. However, this is cumbersome and inefficient. Instead, we can use CIDER directly in the file to evaluate the code at point. There are several ways to do this, and we find two of those already in Emacs as well. One is to place the point at the end of the relevant balanced expression, the relevant form, and to type Ctrl-X, Ctrl-E. And this is running the command CIDER eval last sexp, last symbolic expression. And I can see in the echo area, it has evaluated the hello again symbol. So if I come to the REPL over here and try to evaluate the symbol hello again, it gives me the return value, which is hello once more, this string over here. So this looks very promising. Another way you can you can evaluate code. What's happening? Sorry, okay. Is to, let's see, hello once again. And the third test. So the other way is to be somewhere inside the balanced expression and to type Control, Meta, and X. And again, this has evaluated successfully, and it is running the command CIDER eval define at point. So Control, Meta, X also exists for Emacs Lisp, as well as Control-X, Control-E. So this is great. A third way is to be in the form and to type Control-C, Control-C, and again it does the same thing. It evaluates the code. So if I now type in this symbol, it will give me the desired return value. So this is the benefit. Instead of having to to copy and then to come here and to paste it and then hit the return key, you see? So it's easier to use CIDER to evaluate code interactively in its context. So this looks very promising because now I can dismiss the REPL and start writing my code without needing it to evaluate every little thing at the time. So let's come here and start writing a function. So defn is the keyword we need to declare a function. Then we give the function a name. So I will call this hello world. And then we can specify an optional documentation string, a doc string. You can see at the lower part that the ldoc package of Emacs is providing me hints as to the arguments that I am passing to defn in this case. And when an argument has a question mark next to it as a suffix, it means that it is an optional argument. So optionally, I can define a documentation string here, or I can proceed directly to the params, which are the parameters of this function, the arguments that we give to this function, and then the body of the function, the definition, the substance, what this function actually does. I will define a doc string now. Greet the world. So this is a documentation string. No need to worry about the attribute map. This is a more technical topic. Perhaps in future videos I will delve into such technical issues with Clojure, but for now we just want to get an idea of the big picture. So now I want to define arguments for this function. This is a vector, and vectors in Clojure are specified with the brackets, with the angled brackets, like this. Now it is an empty vector, so I have not declared any argument for this. Very simply, this means that I wanted to very simply and unconditionally print hello world, this is a function. Of course, you can just have this and evaluate this directly, but now I want to define a function so that we see what we have. So I have written it, and now I want to evaluate it. So I type control meta and X. This is the most convenient for me, and there I have it. It has been evaluated. I can see it in the echo area. So I will now bring up the REPL with control C, control Z. Control C, control Z allows you to flip between the file and the REPL associated with it, so it is very convenient. Now I want, let's dismiss the other file for now. I want to run a function now. So if I want to run a function, to evaluate a function, I have to use it like this because this is Lisp. So you enclose it in parentheses. In this case, it is the symbol hello world and then no further arguments. So I will hit the return key, and it is printing exactly what I asked it to print. Hello world, this is a function. So this is very good. Let's go back to our file. Let's dismiss the REPL. No need to keep it around for now. And let's now define a function which we will call, let's call it hello name. And I will say now greet name. I am capitalizing name because this is a convention in Emacs Lisp where you are capitalizing the arguments of the function. I have noticed that in the Clojure community they are not doing this, but I am not sure why. I think it is a good convention. Anyhow, I want now to specify a vector that has one element, so one argument for this function, which is the name. And now I want to print a line which will be like this, hello there, and then the name that I will pass as an argument to this function. Let's evaluate this with Control X, Control E this time, and save our file. Very well. Control C, Control Z to go to the prompt, to the REPL rather. Hello name, and I will give it an argument now. And it is exactly printing what I asked it to print, hello there, and then prot. So this is very promising. What I want to do now is to write a function that accepts a variable number of arguments. So it has rity, as it is known, argumentness is called rity, so the quality of arguments associated with the function. So it has variable rity. Let's say hello name or world. Let's call it like this. Greet the world, greet name if present, else the world. Okay, this is the docstring. When you have variable rity, you have to specify the conditions that apply for each case when you have the desired number of arguments. So now I will have, when we have the name argument, so when we have one argument, I want it to print a line, and this line will be the same as above, hello there. I could have used the above function, but I am now typing this out for didactic purposes. So this is my scenario where I run this function with one argument. And then I want to also specify a condition where I am running this function without any arguments. So in this case, I want to just say hello world, no arguments here. Okay, let's evaluate this. Very good. And let's go to the repo. So I want to run hello name or world, this one over here. Let's run it first with a name. So I am giving it an argument and I am hitting the return key. It is saying hello there and then the name. Let's run this again, but now without an argument. And now it is running the condition without an argument. So hello world, no arguments here. This looks very promising. When we are defining the list of arguments, we can pass a rest parameter. Let me show it to you in practice what this is. Hello, name, and rest. Let's call it like this. Greet, name, and all the remaining names, and all the other names, like this. Okay, so I will show you now first without variable rity. Let's see it like this: name, and then the et sign, which means rest. So the parameter here is a list that will be passed to this function. We will see it in practice. It is a list whose length we do not know. So I want, very simply, just to show you the return value, I want to have format hello, and then here is the name, as well as, and here is the names. So name and names. Let's evaluate it, and let's go to the repo. Hello, name, and the rest. So one name, and then I will give it two more names. So notice that the names, as I said, is of indeterminate length. So I have now given it for the names part. So for this part over here, this parameter, I have given it two strings. Let's see how this will be printed. You see that my first argument is printed here as expected, and then the rest, so the names, what is denoted by the et sign at the argument list, is a list of strings in this case. So if I want to prettify this so that it says hello name and then hello for each of the other names, I have to process this list so that it looks nice and tidy. Let's run some REPL here to see how this works. Let's define the names. Define names, and I will define now a list of strings. So 1, 2, 3. So I am just defining this variable so that I don't have to print this list the whole time. Let me just double check. So it is doing the right thing. It is printing this list of strings. What I want to do now is a few things. First, I want to convert this list of strings into a single string. Because it is a list, I want to run the function apply. And I want to apply to this list, so to the names list, I want to apply the function which joins multiple strings into a single string. And this function is called str, so string. And I want to add this variable now, which is the same as adding directly. Let me see if I can find it. So it's as if running directly this. So I could have replaced names with this and with a quote like this. Let's see it in action first, like this. So you see what it does, but let's do it now like this, names. Okay, so it takes those three strings and it runs the string command, the string function on each of those elements of the list. So now I have all those strings joined into one. As it is now, it is not very helpful because it is not readable. So I want to do something else. I want to take that list and I want to interpose some delimiter which will make it easier for me to read. So we have interpose, and interpose accepts a delimiter, a separator. In this case, it will be a comma and an empty space. And then you just give it a list. So I could just give it like this. Let's see. You will see that it does exactly what I want. It inserts the separator between the elements of the list. So you see it's 1, and then it's the separator, and then it's 2, and the separator. Okay, let's do this with the names as well. Same thing, so I can make some progress. We can, of course, now run this with this. So let's see how it will work. So I want to apply the string, and I want to apply it to the interposed list, so the names with the commas in between. And now I am getting something which is much easier to read. So this is very helpful. Let's go then back to our file over here. And now that we have learned this, we can, of course, process the names over here. But rather than make this very complex, let me define a helper function, which I will call hello, and then interpose, or rather comma separated strings, like this, and then separate list of strings with a comma, like this. So we have what I copied earlier, and here it will be the strings. Sorry, I forgot to add the argument. So strings. So I want to do exactly this. Let's balance our parentheses. So let's see what we have with this first. Let's come to the REPL. So I want to call this function with the names variable that I defined earlier. Will it do the right thing? Okay, it does the right thing. So now I want to take this function, and where we are over here, let's make it a bit easier for you to read. So I have it like this here, and so like this. By the way, I recently installed Evil Mode, but it has been a long time since I used the Vim, and I have forgotten everything, so it's a bit awkward now. The reason I did this is because I have suffered an injury on my left hand, and I can barely move it, and I have difficulty with several motions here. So this is why I am a bit awkward with my typing. Anyhow, we are here, and now I want to process those names. But before I do that, let me remind you how it was. Let's paste this here, but let's keep it like this. Let's remind ourselves what this was doing and why we needed this helper function. We can find it actually by oops, sorry. Here it is. So you can see when I was running this with the rest argument, it was producing a list like this. So the whole print was not very nice. Whereas now I want to prettify that list, which is with the variable number of strings. So I want to have it like this, and then to have this over here and close my parentheses. So this looks correct. So what I want is the rest argument to process it this way, so to add the comma and to get a better result. So I am evaluating this function anew. Let's go back to the REPL. Where was it? This thing over here. And we want to get rid of this. So what I was running earlier, let's see if it does the right thing now. Now it looks much better. So you see, it no longer is a list. It now produces a much easier, a result that is much easier to read. So this is the idea, folks. This is the idea with the development of Clojure code. You are using the REPL when you need it, but with the help of CIDER, you can evaluate code directly in its context, so you don't need to be copy-pasting forms. You don't need to engage with that error-prone activity. You can just stay focused in the file, and when you need the REPL, you can just switch to the REPL. But normally you won't be switching that much when you have a CIDER here, which can evaluate everything interactive. So that's all for now. I will be doing more videos about Emacs, Clojure, and related topics, but it will be one small step at a time. So, thank you very much for your attention, and goodbye. Take care. I am closing now.